Hello and welcome to CommunicAsia 2022 and to our session on SRV6 Beyond the Hype. My name is Nitin Vig and I'm joined today with Aditya Kaul. We are both solution architects in Juniper Networks APAC team. And it's good to see CommunicAsia coming back into the in-person event. Unfortunately, we are not able to join the physical event, but we're very excited about this event and the topics that are being discussed today, all the way from 5G to AI automation, security, deployment of 5G, etc. And that brings me to this topic for us for today, which is segment routing V6. Last year, Aditya and I at the CommunicAsia 2021 spoke about the architecture changes that are happening in service provider networks because of 5G. And this year is kind of like a continuation of that topic where we want to dive a little deeper into a specific technology, which is segment routing V6. There's been a lot of hype around segment routing V6 over the last 2 to 3 years. And today we want to share with you some ground realities about how segment routing V6 specifically is performing, and how service providers are adopting it, and how do we see the future of this technology. So what we're going to do in this session today is that we're going to start by looking at the industry outlook, and then look at some experiences that we would like to share with you around implementation of SRV6 and the challenges associated with it. And then finally, we'll talk about how SRV6 lends itself to the future use cases for 5G and beyond. So if you think about the way networks are getting built for 5G and for beyond, one of the key things that's happening there is the scale at which these networks need to be built. These networks are eventually expected to handle the size of maybe greater than 100,000 routers inside the network. And they need to be very carefully planned in terms of how we segregate these networks into domains. How do we ensure end-to-end communications can happen across these domains in a much simpler manner? How we handle things like network resilience. How do we differentiate services using technologies like network slicing? If you think about the integration between 5G and the cloud, how do we make sure that this integration becomes more seamless inside the network? And last but not the least, how do we make all of this happen in the existing ecosystem where there are brownfield networks that already have that service providers have already deployed, and how do we build new technologies on top of that? So these are some of the challenges that service providers are grappling with. They are already in the midst of doing deployments to address these challenges. And in all of this context is where segment routing V6 fits in as well. And one of the key things that has been a driver for segment routing V6 is that how it brings simplicity inside the network. So, as we drive these large networks, one of the key objectives is to ensure that we can still keep these networks simple, because without simplicity, it's going to be a nightmare managing these large networks. So that's where SRV6 fits in. And what's all the hype about around SRV6? The promise of SRV6 essentially is around some of these topics that you see here. The first one is operational simplicity. It brings about a way for you to build out a single data plane across the network that is stateless and that's programmable. And we'll talk about some of these aspects as we talk about how these are getting implemented inside service provider networks. The other key thing is high availability. Some of the inherent capabilities of segment routing generally and SRV6 in specifically allow it to build the protection or high availability into the IGP protocols itself using technologies like topology independent LFA. And SRV6 specifically also adds some additional capabilities in terms of high availability by introducing load balancing mechanisms using things like the flow label. In terms of scale and efficiency, SRV6 has a very important role to play, and this is one of the key factors why it's been very lucrative to service providers to deploy. And this has been around how you can just leverage the scale of IPv6 natively by using simple technologies like longest prefix match or locator summarization to advertise your network all across these 100,000 or more nodes that you're deploying. So it takes away a lot of the complexity that generally is associated with MPLS in terms of the technologies that are required to ensure reachability across such large networks. The next piece is around seamless integration. Since the technology is inherently based on IPv6, it lends itself very well to be deployed in typically brownfield networks where you may have some nodes that are not SRv6 ready but can still be a part of an SRv6 network. We can leverage existing technologies like 6PE MPLS to deploy services on top of SRv6 as well. So it makes it quite lucrative in terms of integrations. This integration also provides us a way to extend the technology into the data centers so that while you deploy this inside the WAN, it also enables you to deploy similar technologies inside the data center, so you can have more seamless integration across for the traffic, whether it's 5G or other kinds of traffic. And we'll talk a bit more about this later in this session. And then last but not the least is around application-aware routing. The promise of SRV segment routing in general and SRv6 has been around how it makes the networks more programmable by putting all the state at the head end of the routers. So with this, it makes it much easier for applications to define how they want app routing to happen for their specific requirement, and then they can program that very easily on these routers using SDN controllers, etc. So that's another key highlight for SRv6. So that is kind of what the promise of SRv6 is and how it's been looked at as a technology, for adoption inside service provider networks. But now let's maybe take a look at what the reality around SRv6 and SRMPLS is. So I mentioned SRv6, and then segment routing, when deployed in its native form, can also be looked at as SRMPLS. So deploying segment routing using the MPLS technology or deploying it with SRv6. So service providers have been looking at these options. And if you look at this chart here, it gives you a view of how both these technologies are progressing. One is as per geographies. As per geographies, you can see that APAC is a leader in the adoption of SRv6. So 60% of the operators are looking at implementing SRv6 directly inside their networks. And a large percentage have also looked at SRMPLS. But SRv6, a lot of the traction is coming from APAC. There's a multitude of reasons behind this. One is, of course, the kind of scale that we see in the APAC region. The other is also around, when the service providers have picked up the technology waves. So, some have completely skipped the SRMPLS wave and moved directly to SRv6. So that's also a contributing factor. And then we are slowly seeing the deployments, gaining traction in Americas and the EMEA region as well. Now, overall, if you see in terms of deployments, SRv6, of course, currently is only 10% of the deployments across overall in service provider networks, but that is generally because SRMPLS has been around for longer, and it we'll slowly see this graphic also move towards a more equivalent deployment across both these technologies, and that kind of shows in the interest that we're seeing in these technologies. So definitely there's a lot of interest for SRv6, and we expect that will translate into more deployments in the near future. So let's now take a look at the standards and the evolution. So while there is a lot of promise around SRv6, it's also one of the key things that we want to talk about in this session is to cut out the hype and to look at what really is ready to consume and what's still cooking in the kitchen and still needs some work either at the standardization bodies or vendor implementations, etc. So what's ready to consume? Some of the technologies are quite mature and are ready to, ready for deployment inside your networks. Technologies like TILFA, they've been around for a while. Prefix summarization, it's an inherent feature of IPv6. It's been around for a while as well. Flexible algorithm, or flex algo as it's known as, there is stability in how flex algo is getting deployed inside service provider networks as a way of implementing network slicing. And then there are other technologies like how do you implement VPN services, how do you use SR policy, OAM, and also around SRV6 and MPLS interworking. So these are technologies that have gone through standardization and are also readily available in a multi-vendor environment for you to deploy inside your networks. However, of course, there are some areas that still require work and that are under discussion. A major one of those is the SRH compression, the additional overhead that comes with deploying the segment routing header in SRV6. And there's a lot of discussion happening in the standard bodies around the right way to address that. There are compression techniques like CSID, BSID, and UID SR that have been in discussion. And then there are some mapping technologies like CRH. So from a Juniper perspective, we've already implemented the mapping technology, which is CRH, and it's available in our platforms today. And then from a standardization perspective, there's been some validation around the CSID technology, and it's still being it's still going through the validation process through some of the standard bodies like the 6-man, etc. So this is an area where there are some vendor implementations already available, but an area for you to look at carefully if you're looking at implementing SRH compression inside your network. Similarly, around multicast, both segment routing MPLS as well as SRV6, there is discussions ongoing as to how this should be implemented. One of the technologies under discussion is BEER, both for MPLS as well as BEER in V6, specifically for SRV6. Plus, there's also discussions around other ways of implementing multicast, such as P2MP and BGP multicast. So another area for you to look at carefully in terms of deployments, etc. And last but not the least is around telemetry and analytics. As we deploy out these networks, it's very important that we can get a lot of metrics from these networks so that we have an exact view of how the technologies are behaving and performing inside the network. So with that said, this is to give you a high-level view of where the standards are, how it's evolving. But let's peel the onion a little bit more and look at exactly how service providers are implementing it, what kind of challenges they're seeing. And for that, let me hand it over to you. Why don't you walk us through what's happening in the industry and how service providers are adopting this?
Thanks, Nitin, for providing the SRV6 industry update. So let's talk about SRV6 implementation experience and some challenges. And so SRV6 certainly is a technology which will scale the future architectures while keeping them simple from an operational perspective. Meanwhile, the other important aspect for any technology evolution is to make sure it's an industry-grade technology and standardized across all the vendors. Now, this gives our customer a fair choice. Also, very important, it's a production-ready and has no vendor lock-in. Well, from that perspective, most of the vendors, including Juniper, have been investing time and effort for multi-vendor interop at ENTC. We've been quite successful in validating SRV6 as a protocol and also validating various use cases associated with SRV6. So vendors like Juniper, Cisco, Huawei, and ZTE and others have been participating at most of these events across all these years at ENTC. So, for example, in 2020, the year we validated TILFA and major services like L3VPN, EVPN across SRV6 data plane. Also, this included some of these services being steered through SRV6 traffic engineering tunnels. While in 2021, we validated 5 more EVPN use cases. And also, most important, we validated FlexAlgo definitions, which are fundamental to SRV6 network slicing use cases. And finally, in 2022, we can certainly see most of these production-grade use cases working across most of the vendors to make sure we can go ahead with multi-vendor SRV6 deployments. So in terms of deployment, it's very important that we look at L3VPN interworking across SRV6 and MPLS, and that's something which we have done during the validation in 22. So this is an interesting slide. This slide basically talks about SRV6 ongoing deployment at one of our customers. XL Axiata in Indonesia. So XL is a major telecommunications provider in Indonesia and had released an RFP as they had a mandate for evolving and scaling their network for future 5G expansion. Meanwhile, SRV6 was one of their mandatory compliance, and the reason was quite obvious. They wanted to simplify their architecture by removing protocols like LDP, RSVP, and BGP-LU, while they also wanted to scale their network for future services rollout. So from a simplification perspective, they wanted SRV6 as their fundamental building block. So now, what was Juniper's strategy? What were our challenges? So challenge was essentially that the network was a multi-vendor, brownfield, fragmented network. So if you see the geography of Indonesia, it's a collection of multiple islands. So to address that, we needed to have a design to accommodate certain constraints and failover scenarios. Also, some of the equipment lacked SRV6, and we had ongoing 5G rollout plan and deadlines. So looking at these challenges, the way we approached, and we had a pragmatic approach. We wanted to leverage the install base which was existing in the network and coexist with the old platforms. So the approach we took was, first and foremost, let's dual stack first, enable SRV6 where possible, and do the SRV6 MPLS interworking with the existing devices which potentially could not support SRV6, so that there is service and business continuity. We wanted to focus first on the network and SDN later, because there were aspects within the network which we wanted to address first. The outcome was essentially to simplify the architecture using SRV6, scale the network using SRV6 for 5G expansion, and also roll out future use cases like network slicing and dynamic traffic engineering. So we had the objectives. So this slide basically is a representation of a high-level transport architecture at XL Axiata built on top of SRV6. So we had the objectives of simplification to achieve a robust architecture. And for that, we segmented the network into individual RAN regions while connecting them through a converged IP backbone. Now, from scale perspective, the AG aggregation routers, which play the role of region border routers, run multi-instance ISIs. Now, this is to ensure that all the routes or state is confined to individual RAN regions and not really leaked into the IP backbone and vice versa. Also, to ensure that the state within one RAN is not leaked across to the other regions. That helps us scale within the region. Now, for transporting a user service, only a summary IPv6 route is used to reach the destination. This provides us a very scalable approach wherein each individual RAN region could potentially grow, and also within the IP backbone perspective, you still have enough amount of capacity. Meanwhile, for service network slicing, a combination of flex algo and tactical traffic engineering, which is built on top of SRV6, is going to be deployed in IP backbone. In future, these will be managed at the SDN orchestration layer. Now that is to further simplify the operation aspects. So this in turn provides you a view of the high-level transport architecture which we are designing at XL Axiata. So the key enabler, or I would say the key architectural enabler for XL essentially are SRV6 locator summarization and multi-instance ISIs. Now this makes sure that the state remains within the regions to further scale the network, and also future-proof the network to accommodate services like IoT, Industry 4.0, private 5G, far edge compute. Now, it's also important from business and services continuity perspective, provide a seamless interworking mechanism for MPLS. And this is essentially important during the transition towards SRV6. Having said that, this is an interim strategy. if till the entire network evolves towards SRv6. Now, this is a very important slide and a very interesting slide. What's the key consideration, or I would say recipe, for a successful multi-vendor SRv6 deployment? So we have taken a 3P approach, which essentially means plan, 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 which means you have to plan ahead and have a very proper planning in advance. And what essentially are the areas we need to focus is SRv6 locator addressing, end user services, and interworking with MPLS. So if you see the locator addressing, there are some design prerequisites and different methodologies which we could potentially adopt. One, wherein you could use a GUA address space or ULA address space. From our perspective, what we have recommended at our customer is to use GUA for the infrastructure and services around the ULA. Now, this is a potential option. It depends on the network mix you would have. The second important thing when we discuss locator addressing is the locator block length. Now, this needs to be planned ahead, and this basically would depend on the vendor mix you would have. Some vendors might have a preference due to the compression SID. For example, in NextSID, it prefers 16, 32, and 48 locator block length, while replace CSID prefers 48, 56, 64, 72, and 80 locator block length. And we would suggest that this is an area where you would have to invest a certain amount of time before you go ahead with the high-level design. The second aspect, as we said, is services. Now, whether services are global internet, L3VPN, EVPN, they need to be based on services BGP-based overlay services draft. SRv6 SID structure sub TLV is one way to provide those services, and it is important that you plan, verify, and validate the use of sub TLV for some of these L3 services. Another area which is important in terms of validating services is OEM, and we'd suggest to plan for a standardized OEM toolkit, which essentially works across all the vendors. Third, and very important aspect is interworking with MPLS. Now, we need to plan for seamless interworking with existing MPLS transport and services for two reasons. One, essentially to provide a seamless integration of SRv6 while still retaining business continuity for providing services on MPLS. So the coexistence with MPLS could potentially be one way, one interim way towards the use of single IPv6 data plane at a late point. So the important aspect would be to have an interworking gateway functionality somewhere in the network, which would provide you a way to interact with both MPLS end user services and SRv6 end user services. Another option could potentially be two domains, which are SRv6 in nature and MPLS in nature, and which have certain interconnectivity between the two till the whole network evolves towards SRv6. Next slide, please. So I guess we have talked about the benefits and some key considerations for deploying SRv6. So Nitin, what is your view on some of the upcoming SRv6 use cases?
Yeah, thanks, Aditya. And I think it's an excellent overview in terms of looking at what's real and what can be deployed today. Maybe let's look at what's in the future for SRv6 and how does it solve some of the challenges that we discussed upfront. So one of the challenges, definitely that service providers are looking at deploying in the most efficient manner is network slicing. And if you look at network slicing, there are multiple ways that this can be done, and there are multiple aspects also that need to be looked at on how this needs to be done. So let's look at those aspects and then look at what role SRv6 and the technologies associated with it are going to play in that. So the first thing when we think about network slicing is to think about the overlay slices. These are basically the service slices that need to be built that are going to connect the RAN and the core via the transport. So as the UVs attached to different network slices, how do you carry that traffic into the transport domain, and how do you hand that off into the right parts of the core network, whether it's distributed or regional core. The next part is the underlay mapping, and this is where SRv6 and FlexAlgo play an important role. So this is about building out the traffic engineering paths inside the network that gives you the mapping of these overlay services to the underlay. Let's say, for example, if you're looking for an EMBB or a URLLC service, then how does that URLLC service that the UV is subscribing to map to the actual underlay path? So this is driven through building out topology slices using technologies like FlexAlgo, and then combining that with SRv6 for propagation of that information and to do the stitching of the overlay slices to the underlay mapping. However, again, there is more granular control that we can do even beyond these high-level topology slices that we build, and this is done through the next phase, which is the resource guarantees. So you can still have the application of slice-aware quality of service that gets implemented across the network for these specific slices, or making them even more granular, within each slice, in terms of how we deliver the service and how we build the hierarchy of services, etc. This is a very intricate part of the deployment, and it's going to be very important in terms of differentiating your services against competitors from an SRv6 or from a 5G perspective. Over and above this, we expect to see more things happen, like service assurance. Like once you've built these slices, once you build the guaranteed SLAs on top, how do you measure these services? So using technologies for service assurance, from a Juniper perspective, we have some active assurance solutions that sit on top of these slices and underlay and overlay slices to look at how these slices are performing and whether they're meeting their KPIs or not. And if they are not, how do we dynamically take action against that? And last but not the least is around end-to-end orchestration. It's not just about building these slices inside the transport. It's making sure that it kind of combines well with what's happening in the RAN and inside the 5G core, so that we can orchestrate this solution end-to-end. So in summary, SRv6, FlexAlgo, these technologies are going to play an important role from the perspective of network slicing. The second one that I want to talk about is what's happening inside the data center, because we spoke about how we do things in the WAN, but from 5G and perspective and beyond, the cloud or the telco cloud is going to play a very important role as well. And so far, these two domains have been kind of delineated, at these intersection points where, the technologies inside the data center are primarily around EVP and VXLAN. And, in the WAN, we're looking at technologies like SRv6. So how do we do a better integration of these technologies? So there's already discussions ongoing at this point about using EVP and SRv6 in the data center architectures. This is expected to be easy to adopt, considering that the platforms today are already V6 ready. So this is something that's already in discussion. It helps with the introduction of EVPN and SRv6. It helps to reduce the blast radius to have much higher segmentation of tenants, etc., inside the network. The second piece is looking at traffic engineering inside the data centers. So far, the way the data centers are built, they're always, they have sufficient bandwidths available to be able to meet the demands of the services. However, we expect that there will be requirements for more granular control inside the data center fabrics as well. And that's where SRv6 can help to build out these different parts within the data center fabric for traffic engineering. And last but not the least, and this is the key point, is how do we integrate what's happening inside the data center with what's happening in the WAN? So of course, by using technologies like SRv6 both in the data center and in the WAN, we make this integration much more seamless, so that from an underlay perspective, your data plane is running on SRv6 through and through. And then from an overlay perspective, we use technologies like EVPN, which can be extended both into the data center as well as in the WAN, so that from an integration perspective, it becomes seamless end to end. So that's where we see the future use cases. Of course, there are going to be many more in the future, but for now, these are the two key ones that we see there's a lot of active work happening. And with that, let's quickly summarize this session on what we've discussed today and where we see things headed. The first one is about the SRV6 evolution. SRV6 has been around for the last 3 years, and it's seen rapid evolution in terms of the standards that are ready. But it's very important also to remember that there are standards that are still, in building, and it's very important to be cognizant of that fact and choose your technologies and make choices, based on that. The second part is around the deployment experience. As Aditya mentioned, the key here is planning. Plan your networks, do the interrupts, plan, test, and validate your networks to be sure as to that they are meeting the requirements that you have, in terms of their readiness. And last but not the least is the future use cases. So definitely network slicing in the data center. There's also discussions around how SRV6 might have impact in other areas like the mobile user plane, etc. But these are things that we will see how they evolve in the future. So please engage with your vendors, with the standardization organizations to bring your use cases and to help this technology flourish and get deployed successfully inside your networks. So with that, we'd like to thank you for your time, and we hope that you have a great event, and hopefully see you in person next year. Thank you.